Welcome to ITEINC Introduction to Computing. Let us discuss first the computing disciplines and majors under ACM. The field of computing has expanded rapidly over the past 10 years, and students need more information about the field and its related careers. All computing is based on the coordinated use of computer devices called your hardware, and the computer programs that drive them called software. And all software applications are built using data and process specifications called data structures and algorithms. Let us talk computing disciplines under Association for Computing Machinery. So we are going to discuss some of the computing disciplines like computer engineering, computer science, information systems, information technology, and software engineering. So let us first tackle computer engineering. So computer engineering typically involves software and hardware and the development of systems that involve software, hardware, and communications. But computer engineering is considered as a discipline that embodies the science and technology of design, construction, implementation, and maintenance of software and hardware components of modern computing systems, computer-controlled equipment, and networks of intelligent devices. Computer engineering students study the design of digital hardware and software systems, which includes communication systems, computers and devices that contain computers. Programming is focused on digital devices and their interfaces with users and other devices. Traditionally, computer engineering is some combination of both electrical engineering and computer science. It has evolved over the past 4 decades as a separate discipline, although intimately related to computer science and electrical engineering. An important area within computing engineering is the development of embedded systems. Devices such as cell phones, digital audio players, digital video recorders, alarm systems, X-ray machines, and laser surgical tools all require integration of hardware and embedded software and are all the result of computer engineering. Computer engineering is solidly grounded in the theories and principles of computing, mathematics, science, and engineering, and it applies these theories and principles to solve technical problems through the design of computing hardware, software, networks, and processes. Computer science. Currently, the most popular of the computing disciplines tends to be relatively broad and with an emphasis on the underlying science aspects. Computer science is rapidly changing and will continue to change for the foreseeable future. Computer science spans a wide range from its theoretical and algorithmic foundations to cutting-edge developments in robotics, computer vision, intelligent systems, bioinformatics, and other exciting areas. Computer science spans the range from theory through programming to cutting-edge development of computing solutions. And it also offers a foundation that permits graduates to adapt to new technologies and new ideas. The work of computer scientists falls into 3 different categories. First, we have designing and building software, developing effective ways to solve computing problems such as storing information in databases, sending data over networks, or providing new approaches to security problems, devising new and better ways of using computers, and addressing particular changes or challenges in areas such as robotics, computer vision, or digital forensics. Most computer science programs require some mathematical background. Actually, they develop effective ways to solve computing problems. For example, computer scientists develop the best possible ways to store information in databases, send data over the networks, and display complex images. Their theoretical background allows them to determine the best performance possible, and their study of algorithms helps them to develop new approaches that provide better performance. Information systems. Essentially, this is computing in an organizational context, typically in relation to businesses. IS, or information systems, specialists focus on integrating information technology solutions and business process to meet the information needs of businesses and other enterprises, enabling them to achieve their objectives in an effective and efficient way. Information system is concerned with the information that computer systems can provide to aid a company, nonprofit, or governmental organization in defining and achieving its goals. It is also concerned with the processes that an enterprise can implement and improve using information technology. This discipline's perspective on information technology emphasizes information and views technology as an instrument for generating, processing, and distributing information. Professionals in the discipline are primarily concerned with the information that computer systems can provide to aid an enterprise in defining and achieving its goals, and the processes that an enterprise can implement or improve using information technology. IS professionals must understand both technical and organizational factors, and must be able to help an organization determine how information and technology-enabled business processes can provide a foundation for superior organizational performance. They serve as a bridge between the technical and management communities within an organization. The information system specialist plays a key role in determining the requirements for an organization's information systems, and is active in their specification, design, and implementation. As a result, such professionals require a sound understanding of organizational principles and practices so that they can serve as an effective bridge between the technical and management communities with an organization, enabling them to work in harmony to ensure that the organization has the information and the systems it needs to support its operations. Information systems professionals are also involved in designing technology-based organizational communication and collaboration systems. Information technology. It focuses on computing infrastructure and needs of individual users. It tends to involve a study of systems, perhaps just software systems, but also systems in support of learning of information dissemination. Information technology is a label that has two meanings. In the broadest sense, the term information technology is often used to refer to all of computing. In academic or academia, it refers to undergraduate degree programs that prepare students to meet the computer technology needs of business, government, healthcare, schools, and other kinds of organizations. In some nations, other names are used for such degree programs. Information technology is a label that has two meanings. In common usage, the term information technology is often used to refer to all computing. As a name of an undergraduate degree program, it refers to the preparation of students to meet the computer technology needs of business, government, healthcare, schools, and other kinds of organizations. IT professionals possess the right combination of knowledge and practical, hands-on expertise to take care of both an organization's information technology infrastructure and the people who use it. They assume responsibility for selecting hardware and software products appropriate for an organization. Today, organizations of every kind are dependent on information technology. They need to have appropriate systems in place. These systems must work properly, be secure, and upgraded, maintained, and replaced as appropriate. Employees throughout an organization require support from IT staff who understand computer systems and their software and are committed to solving whatever computer-related problems they might have. Graduates of information technology programs address these needs. IT also integrate those products with organizational needs and infrastructure and install, customize, and maintain those applications, thereby providing a secure and effective environment that supports the activities of the organization's computer users. In IT, programming often involves writing short programs that typically connect existing components, or what we call scripting. Degree programs in information technology arose because degree programs in the other computing disciplines were not producing an adequate supply of graduates capable of handling these very real needs. IT programs exist to produce graduates who possess the right combination of knowledge and practical, hands-on expertise to take care of both an organization's information technology infrastructure and the people who use it. IT specialists assume responsibility for selecting hardware and software products appropriate for an organization, integrating those products with organizational needs and infrastructure, and installing, customizing, and maintaining those applications for the organization's computer users. Examples of these responsibilities include the installation of networks, network administration and security, the design of web pages, the development of multimedia resources, the installation of communication components, the oversight of email systems, and the planning and management of the technology life cycle by which an organization's technology is maintained, upgraded, and replaced. Software engineering. It focuses on large-scale software systems. It employs certain ideas from the world of engineering in building reliable software systems. Software engineering is the discipline of developing and maintaining software systems that behave reliably and efficiently and are affordable to develop and maintain and satisfy all the requirements that customers have defined for them. Software engineering is concerned with developing and maintaining software systems that behave reliably and efficiently. They are affordable to develop and maintain, and they will be able to satisfy all the requirements that the customers need. Software engineering is different in character from other engineering disciplines due to both the intangible nature of software and the discontinuous nature of software operation. It seeks to integrate the principles of mathematics and computer science with the engineering practices developed for tangible and physical artifacts. It is important because of the impact of large, expensive software systems and the role of software in safety-critical applications. It integrates mathematics, computer science, and practices whose origins come from engineering. Let's talk about the different mixed disciplinary majors. So we talk about bioinformatics, computational science, computer science and mathematics, gaming and animation, medical or health informatics. Let's talk first bioinformatics. So, bioinformatics combines the elements from at least biology, biochemistry, and computer science, and prepares students for careers in the biotechnology and pharmaceutical industries, or for graduate school in informatics. Some programs may also include elements from information systems, chemistry, mathematics, and statistics. Bioinformatics is an interdisciplinary field that develops methods and software tools for understanding biological data, in particular when the data sets are large and complex. Bioinformatics is a hybrid science that links biological data with techniques for information storage, distribution, and analysis to support multiple areas of scientific research, including biomedicine. Bioinformatics is fed by high-throughput data-generating experiments, including genomic sequence, determinations, and measurements of gene expression patterns. Computational science. Computational science means a science done computationally and serves as a bridge between computing technology and basic sciences. It blends several fields including computer science, applied mathematics, and one or more application sciences such as physics, chemistry, biology, engineering, earth sciences, business, and others. Some programs also include IS or your information system. Computational science is a discipline concerned with the design, implementation, and use of mathematical models to analyze and solve scientific problems. Typically, the term refers to the use of computers to perform simulations or numerical analysis of a scientific system or process. Computer science and mathematics. So, it combines computer science with mathematics, of course. Some of these programs are found at schools that do not have a full major in computer science. Some are found at universities with very large computer science departments. The course, Computer Science and Mathematics, concentrates on areas where mathematics and computing are most relevant to each other, emphasizing the bridges between theory and practice. It offers opportunities for potential computer scientists both to develop a deeper understanding of the mathematical foundations of their subject and to acquire a familiarity with the mathematics of application areas where computers can solve otherwise intractable problems. It also gives mathematicians access to both a practical understanding of the use of computers and a deeper understanding of the limits on the use of computers in their own subject. Gaming and animation. Majors for students interested in creating computer games and computer animations are being developed at a number of schools. These majors have various flavors and may combine either or both of computer science and information technology work with either or both of art and digital media studies. Skills learned in animation will prepare students for a possible future in the television or movie industry in the areas of animation, character and story development, special effects, and motion graphics. In addition, this course is designed for students that want to pursue careers in video gaming. We are referring to character and level design, print advertising, scientific visualization, medical animation, interactive applications, and architectural rendering. Medical or health informatics. Medical or health informatics programs are for students interested to work in a medical environment. Some students will work as technology experts for hospitals, some in public health. Some students may be pre-med or pre-dental. Medical informatics is the intersection of information science, computer science, and healthcare. This field deals with the resources, devices, and methods required to optimize the acquisition, storage, retrieval, and use of information in health and biomedicine. Coursework may be drawn from any or all of computer science, information systems, or information technology in combination with biology, chemistry, and courses unique to this interdisciplinary field. This program covers the multidisciplinary field of informatics, decision support systems, telemedicine, ethics, consumer health informatics, international healthcare systems, global health informatics, translational research informatics, and home care. Students will learn how to design and implement innovative applications and promote new technologies to improve healthcare. Now, we're going to look the different computing disciplines under CHED, or our Commission on Higher Education. Let's start with computer science. So basically, your Bachelor of Science in Computer Science program includes the study of computing concepts and theories, algorithmic foundations, and new developments in computing. Computer science, the study of computers and computing, including their theoretical and algorithmic foundations, hardware and software, and their uses for processing information. The discipline of computer science includes the study of algorithms and data structures, computer and network design, modeling data and information processes, and artificial intelligence. The program also includes the study of the standards and practices in software engineering. It prepares students to acquire skills and disciplines required for designing, writing, and modifying software components, modules, and applications that comprise software solution. Computer science draws some of its foundation from mathematics and engineering, and therefore incorporates techniques from areas such as queuing theory, probability and statistics, and electronic circuit design. Computer science also makes heavy use of hypothesis, testing, and experimentation during the conceptualization, design, measurement, and refinement of new algorithms, information structures, and computer architectures. IS, or your information systems. The BSIS program includes the study of application and effect of information technology to organizations. Graduates of the program should be able to implement an information system which considers complex technological and organizational factors affecting it. These include components, tools, techniques, strategies, methodologies. IS is an integrated set of components for collecting, storing, and processing data, and for providing information, knowledge, and digital products. Business firms and other organizations rely on information systems to carry out and manage their operations, interact with their customers and suppliers, and compete in the marketplace. Graduates are able to help an organization determine how information and technology-enabled business processes can be used as strategic tool to achieve a competitive advantage. As a result, IS professionals require a sound understanding of organizational principles and practices so that they can serve as an effective bridge between the technical and management communities within an organization. This enables them to ensure that the organization has the information and the systems it needs to support its operations. IS are used to run inter-organizational supply chains and electronic markets. For instance, corporations use information systems to process financial accounts, to manage their human resources, and to reach their potential customers with online promotions. Many major companies are built entirely around IS or information systems. These include your eBay, a largely auction marketplace, Amazon, an expanding electronic mall and provider of cloud computing services, Alibaba, a business-to-business e-marketplace, and Google, a search engine company that derives most of its revenue from keyword advertising on internet searches. Governments deploy information systems to provide service cost effectively to citizens. Digital goods such as electronic books, video products, and software, and online services such as gaming and social networking. All are delivered with information systems. Individuals rely on information systems, generally internet-based, for conducting much of their personal lives, for socializing, study, shopping, banking, and even entertainment. Information technology. The BSIT program includes the study of the utilization of both hardware and software technologies involving planning, installing, customizing, operating, managing, and administering, and maintaining information technology infrastructure that provides computing solutions to address the needs of the organization. The most basic information technology definition is that it's the application of technology to solve business or organizational problems on a broad scale. No matter the role, a member of an IT department works with others to solve technology problems, both big and small. There are three primary pillars of responsibility for an IT department. We have the IT governance. This refers to the combination of policies and processes that ensure IT systems are effectively run and in alignment with the organization's need. Next, IT operations. This is a catch-all category for the daily work of an IT department. This includes providing tech support, network maintenance, security testing, and device management duties, and hardware and infrastructure. This focus area refers to all the physical components of IT infrastructure. This pillar of IT includes the setup and maintenance of equipment like routers, servers, phone systems, and individual devices like laptops. The program prepares graduates to address various user needs involving the selection, development, application, integration, and management of computing technologies within an organization. Most information technology jobs fall into four broad categories: computer scientists, computer engineers, systems analysts, and computer programmers. Library and Information Science. So, the Library and Information Science program provides for the study of theory, principles, and practices necessary for the provision of quality and professional library and information services. Library and Information Science is a program designed to provide knowledge and skills in the management of library operations, the systematic organization, conservation, preservation, and restoration of books, historical and cultural documents, and other intellectual properties. The program includes topics on the basic principles and fundamental laws of library science, as well as the appropriate use of information resources. It also teaches essential skills in the integration of information technology and management information system for effective organization, use, and delivery of learning resources and services. Entertainment and multimedia computing is the study and use of concepts, principles, and techniques of computing in the design and development of multimedia products and solutions. It includes various applications such as in science, entertainment, education, simulations, and advertising. The program enables the students to be knowledgeable of the whole pipeline of game development and digital animation projects. The students will acquire the independence and creative competencies to articulate project design and requirements of new projects, not necessarily based on standard templates. The program enables the students to be knowledgeable of the whole pipeline of game development. Computer Engineering. Bachelor of Science in Computer Engineering is a program that embodies the science and technology of design, development, implementation, maintenance, and integration of software and hardware components in modern computing systems and computer-controlled equipment. Computer engineering blends together with computer science and electrical engineering to further advancement in digital technology, computer networking, and computer systems. In turn, computer engineers use their extensive knowledge of hardware and software design and computer programming to make computing platforms and applications more efficient and effective. Seamlessly integrating the latest innovations, computer engineers develop new computer hardware, design and implement software applications, and enhance the capabilities of networks and communication systems. Electronics Engineering. Electronics engineering is the branch of engineering concerned with the practical applications of electricity in all its forms, including those of the field of electronics. Electronics engineering is that branch of electrical engineering concerned with the use of electromagnetic spectrum and with the application of such electronic devices as integrated circuits and transistors. The scope and nature of practice of the electronics engineer shall embrace and consist of any work or activity relating to the applications of engineering, sciences, or principles to the investigation, analysis, synthesis, planning, design, specification, research and development, provision, procurement, marketing and sales, manufacture and production, construction and installation, test, measurements or control, operation, repair, servicing, technical support and maintenance of electronic components, devices, products, apparatus, instruments, equipment, systems, networks, operations, and processes in the field of electronics. The distinction between the fields has become less sharp with technical progress. For example, in the high voltage transmission of electric power, large arrays of electronic devices are used to convert transmission line current at power levels in the tens of megawatts. Moreover, in the regulation and control of interconnected power systems, electronic computers are used to compute requirements much more rapidly and accurately than is possible by manual methods. Let's go to Master of Science in Computer Science. It emphasizes comprehension and understanding of the principles and concepts needed for designing and formulating new tools for applications development, as well as generating new knowledge in the field. Students entering this degree program must have completed undergraduate courses that provide the mathematical foundation for mathematical logic, calculus, discrete mathematics, data structures, computer programming, and data organizations. The Master of Science in Computer Science program aims to provide both breadth and in-depth knowledge in the concepts and techniques related to the design, implementation, and application of computer systems. It emphasizes comprehension and understanding of the principles and concepts needed for designing and formulating new tools for applications development, as well as generating new knowledge in the field. We have the MIT, or Masters in Information Technology. It emphasizes the acquisition of concepts and technologies, preparing and enabling the student for the industrial practice of systems integration, systems administration, systems planning, systems implementation, and other activities that maintain the integrity and proper functionality of a system and its components. MIT program emphasizes the acquisition of concepts and technologies, preparing and enabling the student for industrial practice. The MIT program aims to develop among its students the knowledge of information technology concepts, techniques, and principles, and skills in using IT to provide solutions to problems of organizations and society. MIS, or Masters in Information System, prepares the students for industrial practice in project management, information systems planning, design development, and the management of technical personnel. The MIS program is designed to provide professionals in the information technology industry with advanced training in information systems without requiring them to take extended leaves from their current posts. DIT, or Doctor in Information Technology. It focuses on industry research with a combination of doctoral level coursework. The principal orientation of this degree is the contribution of new knowledge towards the improvement of industry practice of information technology. The DIT offers the research opportunity to extend the knowledge of the discipline of information and communication technology and develop the attributes required to successfully identify, investigate, and resolve problems and opportunities in today's IT industry. We also have your Doctor in Computer Science. It emphasizes focus study and depth of specific areas in computer science. The program is completed primarily through a supervised research that contributes to new knowledge, theory, or technology. The PhD in CS program aims to produce computer scientists who are armed with methods, tools, and techniques from both theoretical and systems aspects of computing, and who can independently formulate computing problems and develop new and innovative technology as novel solutions to address these problems. PhD-TM, or a Doctor of Philosophy major in Technology Management. The program will encompass an integrated multidisciplinary technology and management approach. It is specifically designed to develop interdisciplinary skills and competencies in research and management of technology-dependent enterprises and related entrepreneurship, product, service, and venture creation. Let's go to the different careers path. We have your IS analyst. Information systems analysts are responsible for conducting systems analysis and providing technology project leadership for their organization. One of their main duties includes coordinating operational procedures related to information systems and their management. They are also in charge of programming technical solutions that improve the efficiency of current processes. They also help provide easier access to key information by performing complex data queries in a timely manner. They also improve efficiency of the currently deployed programs. They also create documentations features for the existing applications, as well as analyze business problems and data to develop the solution. They also conduct statistical analysis and modeling to reach business objectives. They also make recommendations based on their findings and present those results and recommendations to managers in their organization. They also establish directions for their organization's automation efforts. A bachelor's degree in computer science, IS, or related field is required for this position. Relevant experience in programming and in similar analysis capacity is generally required or preferred. So, IS must work well with other analysts. They need to have advanced analytical skills and pay strong attention to detail, as well as be able to multitask on a variety of technology projects. So in layman terms, information analysts are responsible for designing and managing information system, as well as analyzing and tracking data needed to facilitate company projects and various operations. So this is the possible salary per year of the IS analyst. Let's go to data scientist. So a data scientist is someone who makes value out of data. A data scientist is someone who knows how to extract meaning from and interpret data, which requires both tools and methods from statistics and machine learning, as well as being human. Data scientists are a new breed of analytical data expert who have the technical skills to solve complex problems and the curiosity to explore what problems need to be solved. They are part mathematician, part computer scientist, and part trend spotter. So a data scientist could have this salary. Let's go to security consultant. So basically, security consultants often work in large organizations and educational institutions, which is having a large digitized databases. Security consultants must be adaptable to each industry they may specifically cater to. They must have good organization and communication skills. They must design or improve a system that protects the institution against internal and external theft or data. Protecting data from terrorist organizations may also be a concern. So security consultants assess all security measures for their organization or for client organizations. They analyze security systems, study potential breaches, and supervise the implementation of the solutions. So the possible salary of a security consultant, let's go to business analyst in reference to information technology. So a business analyst, specifically the IT, focuses on improving operations that involve information technology within a company. The business analyst offers consultation to management in an effort to help the company become more effective. Business analysts help or guide businesses in improving processes, products, services, and software through data analysis. These agile workers straddle the line between IT and the business to help bridge the gap and improve efficiency. The IT business analyst will analyze the hardware or the software and IT services that are being employed in a company. Analysis will have to be carried out in order to determine areas that needs improvement. It is also important to have strong research skills in order to determine the latest trends and solutions. So this is the possible salary of the business analyst. Let's go to business intelligence consultant. So a business intelligence consultant assists businesses with the collection, organization, and use of computerized data. They usually evaluate existing systems and install new software when it is needed to better assess the company's acquired data. By understanding both business management principles and available technology, a business intelligence consultant can improve a business efficiency, minimize operating costs, and increase profits. A business intelligence analyst's main role is to analyze data with the purpose of identifying areas where an organization can improve. They also gather and analyze data with the purpose of providing solutions to potential organizational obstacles. So, the possible salary of business intelligence consultant. Let's go to enterprise architect. So, enterprise architects maintain information technology networks and the different services used by their organization. This work is typically mental, although some physical work may be required, such as driving a vehicle to destinations that require IT services. An enterprise architect is responsible for the upkeep and maintenance of an organization's IT networks and services. Enterprise architects work across the organization, determining the needs of a range of business units and processes. Their tasks performed by enterprise architects include maintaining IT services and projects, keeping the business up to date with new technology, providing feedback to the company on IT works and potential improvements, and working with other staff on a variety of projects. Enterprise architects interact with external customers, developmental teams within the business to work on projects, and senior IT management to help keep all IT assets run properly. An enterprise architect is someone who is responsible for making sure that a company's business strategy uses proper technology systems architecture to achieve its goals. Enterprise architects have an enormous degree of responsibility and typically report directly to the CIO or the Chief Information Officer. They need to keep up with the latest trends in technology and determine whether or not they would be the right fit for a company. So this is the possible salary of an enterprise architect. Let's go to systems analyst. People who wish to work as a systems analyst must be able to think outside the box, finding effective solutions for businesses and other clients. They must be adept at investigating problems and fixing them in the most efficient way as much as possible. A systems analyst is a person who uses analysis and design techniques to solve business problems using information technology. Systems analysts may serve as change agents who identify the organizational improvements needed, design systems to implement those changes, and train and motivate others to use the systems. So, systems analysts must be knowledgeable in programming languages, operating systems, and hardware. Those who are hoping to work in this field must be educated in technology, and they must be able to keep up with the quickly changing world of software. Systems analysts work to optimize user experience with programs. These professionals advise employers and clients on which software they may need, implement the software, and liaise with users to ensure the programs function properly. So the possible salary of the systems analyst. So this is the end of the Intro to Computing Module 1. Thank you for listening. If you have certain questions or clarifications, please write it down and we will tackle it when we have time to have a web conference. Thank you.